The focus of this lesson is on solving a system of nonlinear equations. So we can see from our graph that one of our equations is in fact linear. In fact, it comes from the second equation. So the second equation represents that red line in our graph. And the first equation is actually a parabola, so it's that blue graph, and you can see it's that like upside down U shape. So this is a nonlinear system because at least one of the equations is not linear. So when we look at that graph, as far as solutions go, solutions are points that satisfy both equations. So we're looking for the points of intersection. And we can see, at least from the window that we have there, that there doesn't appear to be any points of intersection. So at the end of going through this process, I would expect there to be no solutions. So that's how you can use your graphing calculator to give you insight into the solution. So let's go ahead and walk through the procedure for solving this system of nonlinear equations. So the first thing is you want to choose whether you're going to use elimination or substitution, but you need to analyze your equations that you have. And in either case, both methods would work, but I would usually choose elimination if I could. And so if you choose the elimination method, you want to make sure that you're left with only one variable at the end. So you want to eliminate in such a way that you're only left with x's or you're only left with y's. So if we look at our two equations, the first equation has an x squared, the second equation has an x. I can't really eliminate those x's well because they're not of the same power. But the y's, on the other hand, that is 3y to the first, and in the second equation it's negative y to the first. So those are to the same power. So those y's would be easy and straightforward to eliminate as long as we pick the correct multiplier. So that's what I would do if I choose the elimination step. So that's going to be my first step. So I'm going to end up solving by elimination. And again, substitution would work well for this, but maybe not as quick. So if I write down my first equation, I have x squared plus 3y equals 0. My second equation is x minus y is negative 12. And I want to eliminate the y's. I can see that I need a multiplier of 3 because that'll give me opposite coefficients. So this will give me a positive 3 in the first equation and a negative 3 in the second equation when I multiply that 3 through. So that's ultimately the goal. So I'm going to rewrite my system by distributing that 3 across the entire equation, just so you guys can see the steps. And then I'm going to go ahead and combine my equations. Now notice the 3y and the negative 3y will add out. But as far as these terms are concerned, this is x squared and this is 3x, so those don't combine. So just make sure you write both of them. Don't try to put them together. Equals your negative 36. So you have a quadratic. So the easiest way to solve a quadratic is get everything on the same side. So I'm going to add 36 to both sides, which leaves me 0 on the right. And then normally I would try to factor, so what two numbers multiply together to give me 36, but add to give me 3. But I know I can't come up with any numbers that are going to do that have ultimately the same signs. So instead I would go through and use the quadratic formula, which means our solutions are of the form opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So if I apply that to the equation I'm working with, b is 3, so the opposite of b would be negative 3, plus or minus that b squared would be 3 squared, which is 9, minus 4 times my a, which is 1, times my c, which is 36, all over 2 times a, which again a is 1. But that gives me negative 3 plus or minus the square root of 9, and then 36 times 1 is 36, times 4 is 144, and then that says minus, so it's going to be negative over all. I usually look at all three of my signs, so negative, positive, positive, so I'm going to know I'm going to be negative over all. And that's all over 2 times 1, which is 2. So this is negative 3 plus or minus the square root of negative 135 over 2. But whenever you take the square root of a negative number, you're left with an imaginary solution. So ultimately, there are no real solutions. So when we look at this graph, this is a Cartesian coordinate plane. It's talking about your real solution. So there's no real solutions. So ultimately, you're done with your process because you have no real solutions.